Now, when we're talking about supplemental lighting for crop production, something we can't avoid is this term full spectrum. Full spectrum is not a regulated term. It doesn't officially, legally mean anything. There are some loosely agreed upon definitions, aims, goals in the light industry, but full spectrum doesn't mean anything. Getting a full spectrum bulb doesn't mean it's good for growing your crop. So that's just something to watch out for. We'll talk more about this here in a second, but just since we're here, we'll catch a couple other things. When you're looking to get a light, while you might be looking past the whole full spectrum part of the labeling, something you might want to think about is, do you want a switch? Supplemental lights, artificial lights can either just turn on as you plug them in and when they get power, or there can be a switch attached to each light. This is really nice, especially for smaller operations, so you can turn them on and off and not have to mess with your whole system. Moisture proofing. This is an option that some producers will add to their lights, but otherwise it's just something that you need to look for as a feature of the lights that you can buy, because of course you very much need this. You are working with a lot of water, growing plants. There's going to be moisture left, right, and center. You need moisture proofing on your electric light. You also, of course, that light better be grounded. Some producers cut some corners by not grounding their lights. You want a 3-prong plug that gives you the grounding, and you want to make sure that there's some kind of safety feature in the light itself, so that maybe there's a fuse or something, so that if this moisture proofing fails, if water touches it, people don't get electrocuted and get hurt or die. One last thing that you will likely encounter when searching for supplemental lights is the option of including a ballast or fixture with the light. It's basically the difference between getting raw lights, like just a light bulb, or maybe a light bulb and a socket. The fixture lets you use the light, unless you're incredibly inclined to build a bunch of your own stuff. The fixture brings in the grounding and the moisture proofing, and the switch gives you something to attach to and hang the lights, and just does something that holds the light in place and then gives you something to work with, rather than just raw lights. And they are cheaper, and you can mess with lights without ballasts or fixtures if you'd like. It's just more complicated. Okay, now we're coming back to talk about this full spectrum. Let's just put up a couple graphs and then we're done. Okay, so I'm going to put 2 light profiles up here. We have wavelength here, so the color basically, and then the intensity, how strong that wavelength is. So this first one, this is a sample of full broad spectrum sunlight. This is, so wavelength, we have all the colors represented, really strong right here on the blues, weaker kind of as it goes with a few bumps along the way. Now this one is a daylight fluorescent. This daylight fluorescent is designed to make it seem to your eyes, to my eyes, that it's just basically like sunlight. But we can see here, it's not the same. We've got some really tremendous differences. Let's see. So we can see basically anywhere there isn't a peak, we've got just tremendous intensity missing from this sunlight. And so maybe to your eyes, to my eyes, these peaks are the important parts to make us think the light's there, right? We've got basically red, green, blue, blue, green, reddy, orange, and this tricks us into sunlight. A plant will notice the difference. A plant will grow weakly under this light. This light is missing so much from this light. And so I guess that's kind of the spin to why full spectrum, full spectrum doesn't have to do anything with plants. Full spectrum is about tricking you and I into into thinking we're outside. So what's missing beyond the intensity difference? Is there anything else happening here? Well, Liu et al. Conducted a study in 2018 using a full spectrum white LED lamp. And they found full spectrum or wide spectrum lights always outperformed narrow spectrum lights. The next thing they found was this little ratio here. Basically, the kind of suggested guide for what color lights each plant or plants are going to need. So blue light is usually up to about 30%. Green light, believe it or not, up to 50%. There have been arguments in the past that plants don't use green light because the green light is reflecting off of them and then hitting our eyes so that we can see them as green. Well, studies have since found out that plants do a lot better with green light and that we can't afford to skip it. Here we go, a big heavy hitter here, 30 to 70% red light. And then distinct from red light, this is far red light. So there we have it. Why full spectrum? Doesn't matter for plant production. What kind of light spread that we need to grow good lights or to grow good plants. How to apply them, over what length of time, how to measure how much you're giving them. All this playing into optimizing plant production, especially under artificial lighting conditions.